A bisector is a line or a line segment that divides something into two equal parts. So a line or a line segment that divides something into two equal parts is called a bisector. Now a bisector could divide a line segment, then it is called a line bisector. So this is a line bisector. Or it could divide an angle into two equal parts, then it is called an angle bisector. So this is an angle bisector. So let us study these in detail. A line bisector is a line which divides a line segment into two equal parts. So it divides a line segment into two equal parts. So we see that this line segment, it could be a line as well as a line segment. So this line segment divides this line segment into two equal parts. The length of each part is x. So it divides the line segment into two equal parts. Hence this is a line bisector. Now we have this line segment AB and we need to bisect it. How do we do that? First, let us mark the points, these endpoints of AB. These are also called the vertices of AB. So these are the vertices or the endpoints of the line segment AB. Now I need to draw the line bisector of this line segment. So, say I take a point here. Now, if the line bisector passes through this point, it will not divide AB into two equal parts because this is much less compared to this. So this point is closer to A as compared to B. So it does not divide AB into two equal parts. If I take a point here, then this point is closer to B as compared to A. So any line through this point cannot be a line bisector. So in order to draw the line bisector of AB, we need to mark a point midway between A and B. So let us do that. We take a scale and we see that the length of AB is 90. It is 90. What is half of 90? It is 45. So we mark a point at 45. Now this point is equidistant from A and B. This distance is equal to this distance. So this point is called the midpoint of AB. Midpoint is equidistant from the vertices of a line segment. So M is the midpoint of line segment AB. Now we can draw our line bisector through M. This is the line bisector. It divides AB into two equal parts. This part is equal to this part. Now an important thing to note here is, I can draw a line passing through the midpoint in this manner. Even this line bisects AB because it passes through the midpoint of AB. I can draw another line passing through the midpoint of AB. So I can draw many lines passing through the midpoint of AB. Are all these lines the line bisectors of AB? Well, yes. All these lines are the line bisectors of AB. Any line which passes through the midpoint of a line segment is the line bisector of that line segment. So a line bisector is not unique. For a given line segment, we can have many line bisectors. Now, does a line bisector bisect a line also? We have seen that a line bisector divides a line segment into two equal parts. But what about a line? Can it divide a line into two equal parts? We have this line AB. Line AB means the line which passes through the points A and B. So we have these points A and B and a line passing through them. This is a line segment. Now this part is equal to this part. So this line segment appears to be the line bisector of this line AB. But since this is a line, I can extend it in any direction I want, because a line extends infinitely in both the directions. So let me extend it in this direction. So I extend it in this direction and get this. Now this line segment does not appear to bisect this line AB, because this part is greater than this part. But this line is the same as this line. This is a line passing through the points A and B. Even this is a line passing through the points A and B. So these two lines are the same. So this is not a bisector of this line. Hence this is not a bisector of this line as well. In fact, there is no way of measuring the length of this part and this part, because a line extends infinitely in both the directions. So there is no way in which we can measure the length of this part or the other part. So a line can never be bisected. We can never bisect a line. Only a line segment can be bisected. So now can you answer this question? Is PQ a line bisector of XY? Well, we see that PQ meets XY at this point. The length of this part is 50 centimeter and the length of this part is also 50 centimeter. So these two parts are equal. So PQ divides XY into two equal parts. Hence PQ is a line bisector of XY. So we can say that yes, PQ is a line bisector of XY. Now let us come to perpendicular bisector. A line is called a perpendicular bisector of a line segment if it bisects the line segment and is perpendicular to it. So there are two things. It should bisect the line segment and it should be perpendicular to it. It could be a line as well as a line segment which bisects it and which is perpendicular to it. So both the conditions should be satisfied. If we look at this line is perpendicular to the line segment AB, but this part is not equal to this part. So this is not a perpendicular bisector of AB, although this is a perpendicular line to AB, but it is not a perpendicular bisector of AB. If we look at this line, it bisects AB because this part is equal to this part, but it is not perpendicular. So this is a line bisector of AB and not a perpendicular bisector of AB. So for a line or a line segment to be a perpendicular bisector of AB, it should divide AB into two equal parts and it should be perpendicular to AB. Now, unlike line bisector, perpendicular bisector is unique. So for a given line segment, we can have just one perpendicular bisector. That is, for a given line segment, we can have only one line which bisects that line segment and is perpendicular to it. Now, where can we see perpendicular bisector? You take a rectangular piece of paper and fold it into two equal parts, then this fold which appears is the perpendicular bisector of the edge of this paper. Now if we have CD perpendicular bisector of line segment AB, then there are two possible cases. We can have CD and AB in this manner, or we can have CD and AB in this manner. Both of them are correct. In this case, D does not lie on AB, but in this case, D lies on AB. So D is the midpoint of AB. So in this case, D itself is the midpoint of AB. So there are two cases when CD is the perpendicular bisector of AB. But if we have CD is perpendicular bisector of line segment AB and M is the midpoint, then there is just one possibility. In this case, M is the midpoint of AB and hence D does not lie on AB. So this is just one possibility which we can have in this case. Now let us come to angle bisector. A line is called an angle bisector if it divides an angle into two equal parts. So it could be a line segment, a ray, anything. But if it divides an angle into two equal parts, then it is called an angle bisector. So this line segment bisects this angle into two equal parts. Hence, this is an angle bisector. An angle bisector forms two equal angles. So this angle is equal to this angle. There are two angles being formed. This angle and this angle. These two angles are equal. They are formed by this angle bisector. And where do we see angle bisector? Take a square piece of paper and fold it along the diagonal. This fold makes two angles. These angles are equal. So this fold is the angular bisector of this angle at the edge. Angle bisector is unique. So we can have just one angle bisector for a given angle. So this is an angle bisector of this angle. It is an angle bisector of this angle. So this angle is equal to this angle. Now if we try to make another angle bisector, let us see what happens. So this is an angle bisector. If I rotate it, then this angle becomes smaller and this angle becomes bigger. If I rotate it the other way, then this angle becomes smaller and this angle becomes bigger. So the angles do not remain equal anymore. So we can have only one angle bisector. Hence, an angle bisector is unique. Now can you answer this question? YP bisects angle XYZ. Is it true or false? Well, we see that YP is a line segment. Angle XYZ is this angle. The angle made here is 15 degrees. The angle made here is 45 degrees. These two are not equal. But we know that an angle bisector makes two equal angles. Hence, this cannot be an angle bisector. So this statement is false. YP is not the angle bisector of angle XYZ.